Hi everybody, welcome to week 7, lesson 1 for year 5 maths. This week we are learning all about data and today we're learning about collecting data. So today we're learning to collect data and we're going to look at what data actually means in a moment. To do this, you're going to successfully distinguish between categorical and numerical data. So looking at the difference between those two types of data. Recognize that surveys and observation are two ways of collecting data. There are many more, but they're the two types we're going to look at this week. We're going to be posing and refining some survey questions. And lastly, looking at collecting data through observation, which is what you'll do today in your activity. So firstly, let's think about what is data. Well, very simply, data is information. That's all it is. So it can be very complex information or it can be very simple. And it can be collected in a whole lot of different ways. So here we've got a tally, which is different types of lollies or candies, and we're not entirely sure what this data is actually about. It might be about how many of these have been sold, but we can see here we've got the type of chocolate bar or type of candy, and then a tally mark next to it, keeping track of how many have been sold or whatever it's keeping track of. It can be as simple as post-it notes with yes and no's on them or responses on them. You can record data in an application. So here we've got an application to enroll in a school. All that is data there. It's all information, things like your name, address, date of birth. All that is all data which is stored somewhere. You might hear data referred to quite commonly with mobile phones. So when we're talking about data there, we're talking about the information that's being transmitted or received to the mobile phone, and that's usually recorded in megabytes or gigabytes, depending on your plan. Recently, we had a really big data collection activity, which is the census. This happens every 5 years. So it was like the last week or the week before, where the government or the Australian Bureau of Statistics is collecting data about the population. So things about how much people earn, what languages they speak at home, how many people live in a house. So again, this is a big data collection activity about the Australian population. And lastly, there's this topic here, which is really, really relevant in today's world, particularly in the last 20, 30 years with the advent of the internet, and this idea about big data. So that's about using really big data sets of information that's gathered from companies like Google or government websites where you've got thousands, millions of people or millions of transactions or millions of bits of information floating around there, even billions, and kind of consolidating them in a single data set or kind of looking at all the different relationships there are between those different data sets and drawing some really interesting conclusions. So this is kind of like the biggest way of thinking about data, and this is probably the most simplest way. So we've kind of got a bit of a progression here. Okay, so now we know that data really just means information. Let's look at two types of data we're going to look at this week. The first one is numerical data. So this is data that can be counted, measured, or represented as a number. So here are some examples. So how old are you? That can be represented as years. So you could say, 10 years. You can make it even more specific, 10 years and 3 months, 10 years, 3 months and 26 days. It can always be represented as a number. Similarly, how much time do you spend exercising each week? That can be represented in hours or minutes, and it can also be counted. So you could say, 3 hours, done. How tall are you? How many books do you own? How much money do you spend? All those things can be represented with numerical data with numbers. The other type is categorical data. Now, this is a little bit trickier. This is data that is not numerical. So, but it can be divided into groups or categories. So for example, what's your favorite ice cream flavor? Well, we can't actually represent that with a number. I can't go 3, but I can say, well, my favorite ice cream flavor is chocolate or strawberry or vanilla. Similarly, what's your preferred way of learning? It might be to read, it might be to listen to something, it might be to build something or make something. What sports do you play? What languages do you speak? So many different examples. Now, over here, with categorical data, some people get a little bit confused between numerical and categorical data. They go, well, I can count how many people like chocolate ice cream. So let's say it's 5 people, therefore it's numerical data. That's not true. we've still got a category of chocolate. That's our category. That's the type of data, and this is just the number of responses. Yeah. Similarly, over here, you might have 5 people who are 10 years and 3 months. Yep. So responses here is separate to the type of data it is. So don't get confused with that. So now we know what data is, and we know 2 types of data, numerical and categorical data. How do we go about collecting it? Well, there's 2 types that we're going to look at this week. Now, these aren't the only ways of collecting data. There are many others, but they're kind of common ways of collecting it, the most basic ones. So firstly is a survey. So a survey is a set of questions that you ask people to find out information or to find out their opinions. Now, a survey can be really basic. It can be done in person. It can be done on a piece of paper, on a scrap piece of paper, or it can be done online using a survey tool. So one of the survey tools you'll see me showing this week will be SurveyMonkey, and there's also an optional activity to do that, to create your own survey on SurveyMonkey. It's a free program. There is a premium version which you can pay for, but you can sign up for free, and you can play around with creating a different survey, and also shows you through the survey process, which we'll look at in a minute. That's a survey. So a set of questions you ask people to find out, to basically gather data from them. The next type is observation. Now, this is where you're watching events or noticing facts unfold. So for example, you might say, what is the number of birds that visit my garden each day over a week? So you maybe set up a camera, or you could be really willing and sit out there and record it with a piece of paper and some tallies. But there you're observing, something that's happening, and then you're recording it down, to be analyzed later. Okay, so let's look at surveys and the process of making a survey all the way through to the very end where you've analyzed your findings and you're presenting the data. So firstly, what you need to do is create a survey question. So this is, what do I want to find out through this exercise? What's the main thing I want to find out from the people that I'm surveying? So you might say, what are people's favorite pizza toppings in stage 3 at Rydalmere Public School, for example? That might be a nice specific survey question or a research question that kind of is the overarching question that you want to ask as a part of this survey. Then you want to design the survey. So this is where you're thinking, okay, well, now I've got my main question or my main research question that what I want to find out about pizza toppings and people's preferred pizza toppings. Now I need to design the survey. So this is the actual questions that are in the survey that people answer. Now you kind of think, well, do I want them to be multiple choice answers? A, B, C, D, and they select one. Can they select more than one? Is it going to be free text response so people can kind of write their answer or write a sentence about it? Is it going to be a numerical response, or a ranking response? That's where you design your survey. Now you can do that on paper, you can do that online, really up to you. Then number 3 is you're collecting your data. So you need to think about, who am I collecting the data from? Actually, you probably need to do that in the survey design phase. And also, who's it going to? How are they going to input the data? How long are they going to have to input the data? How many people is it going to? Once you've collected your data, you need to close off the data. So, okay, no more data coming through. Then you need to sort it. So we're going to look at that today as well. Arranging it, organizing it so you can use it to go on to the next stage, which is analysis or analyzing it. Now, this is probably, we're not really going to look at it so much this week, but this is probably the most interesting part from my perspective of how do you make sense of all the data you've collected. It's very easy to collect data, but how do you actually get that really interesting information about, what does this tell us about people's favorite pizza toppings? And the more variables you collect, the more different types of data you collect. So you might collect data about people's age, their gender, their the languages they speak, their height, blah, blah, blah. The more pieces of data you collect, the more interesting findings or more interesting conclusions you might be able to draw. And then lastly, number 6, which we're not really going to look at so much this week, is presenting the data. So this is like putting in charts, putting in a way that's nice and easy for people to understand what you've found out about this data through your analysis in number 5. Okay, now we've looked at this idea of having a survey question or a research question. So that's something you want to get data about to kind of answer a situation or can help you inform your decision. So let's say in this situation, there's a teacher and they're ordering pizza for their class because they're having a pizza party. And they have 5 different types of pizza available to them. So maybe they're ordering from Domino's, and they're the 5 pizzas that are in their budget or the 5 pizzas that they can get delivered. So they need to find out which pizzas should they order for their class. So they're going to do a survey, and we're going to go through each of these questions here and see which one is the best one for this particular situation. So firstly, what pizza topping do you like? So you say, what pizza topping do you like out of this list? Someone might like more than one. They might not like any of them. It's an okay question, but it doesn't really tell us, let's say it's Hawaiian, barbecue chicken, supreme, vegetarian, and whatever. They might not like any of those. It doesn't really tell us which one is the one they prefer, or, which one they're happy with eating on the day that they have the pizza party. So this question, not particularly great. What is your favorite pizza topping? Very similar. Their favorite pizza topping might not be there. They might be like, well, none of these are my favorite pizza topping. I like anchovies, feta cheese, and guacamole. So again, favorite pizza topping is not really going to cut it. What is the best pizza topping? Not really kind of telling us what the person's favorite the pizza topping the person would like to eat. So they might go, what's the best? Is a very broad idea. It can be like, what's the best one for our class? The person might be very selfless and they might be thinking, well, what's the one that's going to satisfy the most people? I think most people like cheese pizza, so that's probably the best one we should order. It's not really telling us what pizza is that they would like. So this teacher wants to know, how can I satisfy everybody in the class? Not just sort of get like, oh, what's the most general, most popular pizza topping? I'll just order, a dozen pizzas. So again, this is not a great question. What type of pizzas do you mostly eat? This is okay. It's going to tell us, what the person, mostly eats at home. It doesn't really tell us. You could imply that the ones they mostly eat are the ones they mostly prefer, but they might not have a choice of pizza, particularly as a child, you don't get a choice of making the order necessarily. So it might just be like, well, my family likes Hawaiian, but I don't like Hawaiian, but we always get it because everyone in my family likes it. That's the one I mostly eat. So particularly not a great question. This last one here, what is your preferred pizza topping, is probably the one that's going to answer this scenario. It's going to give the teacher the data or the information they want to inform their decision. So what's your preferred pizza topping out of these 5? It's one pizza topping, it's the preferred, so it might not be their favorite because their favorite might not be there. It might not be the one they mostly eat because we know that's a problematic concept. Or it's not the best, it's the one that they prefer to eat. So out of these 5. So this is going to be our research question. Now it seems like a lot of semantics, but it's really important when you're designing a survey question that it's very targeted, it's unambiguous, and it's giving you the data that you want. All right, so now we've looked at refining a survey question. Here are some really useful tips that can help us. The first one is you need to have a clear goal for your survey. So really, what do you want to find out by conducting a survey? Don't just conduct a survey for a survey's sake, because a lot of people sometimes do that, think, oh, I'm just going to gather data, it's going to be great. You need to think, how is this survey data or data collected from the survey going to help us make our decisions or find out something we didn't know? So you need to have a very clear goal, and that will help you formulate your question. Next one is each question should only ask one question at a time. So sometimes people accidentally make a kind of double barrel or triple barrel question. So like, how much do you enjoy our goods and services? Well, goods and services are 2 separate things. So you probably want to say, how much do you enjoy our goods, like our product, and how much do you enjoy the service, for example. Now that's an attitudinal question. That's you might say, somewhat enjoyed, completely enjoyed, or didn't enjoy at all. We're not really doing kind of attitudinal data for this, but it's just an example. This one is don't ask leading questions. So here's a classic example. How helpful were our friendly staff? This is a leading question because it's basically saying you don't really have an option here. How helpful were our friendly staff? Well, here you don't get a choice of saying whether they're friendly or not. And it's also kind of asking you, well, kind of leading you down the path of saying, well, they are helpful, even if not very helpful, like they are helpful in some way. Whereas you could be like, well, they're not at all helpful. So a better question here would be say, well, how helpful or unhelpful were our staff? That gives you the option of saying, well, they're actually completely unhelpful, rather than sort of saying, having to kind of agree with, well, they are a little bit helpful. This one is really important. Avoid absolutes. So don't say, do you always brush your teeth? Instead, how often do you brush your teeth? Might be a better way of asking that question, because always is an absolute. And, sometimes people, they might not brush their teeth for a very good reason. They might be, on a camp or something and they've forgotten their toothbrush or whatever. So they can't actually honestly say, well, I always brush them. Sometimes I miss it. People are human. So here, a better question would be, how often do you brush your teeth? Next one is focus on closed answers. So things like yes, no, multiple choice. You don't want to have, well, depending on the type of survey, you don't want to have kind of free text responses where people can write whatever they like. You kind of want to guide them to, a list of choices. It makes it a lot easier when it comes to analyzing later on. And lastly, make sure if you've got opinion choices that they're balanced. So things like very helpful, helpful, neither helpful nor unhelpful, unhelpful, very unhelpful. That's balanced, rather than saying, here are your options. Our staff were very helpful, helpful, or neither helpful or unhelpful. It actually misses this whole part down here, this other bit about being completely unhelpful. So make sure that whatever options you give, particularly if it's an attitudinal survey, which we're not having to worry about so much, it's balanced. So this is a screenshot of SurveyMonkey, which is a popular survey tool, an online survey tool. Here I've got my heading for the survey. So it's called preferred pizza toppings, and I say preferred pizza toppings for 5, 6R perhaps. And then I've got my first question. Which pizza topping below do you prefer? Then I have multiple choice. So here I've got 6 options, and the respondents, that's the people who are answering the survey, so presumably students, would select one of those. I also have some other questions, what is your age and so on. That can also tell me other things, for example, 10-year-olds tend to prefer cheese pizza, whereas like 12-year-olds tend to prefer meat lovers pizza. So that might help me with that. So here are the survey questions, what's pizza topping that you prefer, what's your age, and what is your gender as well. Now here, about age, before I mentioned that age is a numerical type of data, it can also be represented categorically as well. So here, instead of having the actual age, so someone might say, 10 years, 4 months, here I can actually group people into categories. So people who are under 18, 18 to 24, 25 to 34, and so on. So age can also be represented categorically. Now here, everyone will be, in our class is under 18, but I could kind of group it, 9 to 10, 11 to 12, and so on. Lastly, I did mention another way of collecting data is through observation, which is probably a lot simpler than doing a survey. Although survey, you can find out people's preferences better and people's opinions about things better. So here, you wouldn't kind of collect this data. What is the most common type of bird to visit my garden in a day? You wouldn't use a survey to collect that because birds can't answer surveys. But you probably have to sit out there either with a camera or whatever and record the number of birds. So here, a good way of recording it is using a table. So in one column, I've got the type of bird, and the next column, I've got a number, and I'm just keeping a tally. So here, I can see that minor birds are the most common type of bird to visit my garden in a day. Okay, so here are our main ideas from today. Firstly, data just means information. Secondly, numerical data is data that can be counted or measured. So things like weight, height, age, distance, all can be measured and counted on a scale. Categorical data, on the other hand, can be divided into groups. So things like nationality, favorite color, favorite sport, favorite TV show, they're all categories. So they're not represented by numbers. They can be counted, but they're their own groups or categories. There are two ways of collecting data, either through survey or observation. If you're using a survey, the most important thing is to make sure your survey question is collecting the data you want. So it means that you might need to refine your survey question so it's specific, it's unambiguous, and it's collecting the data that you want. And lastly, simple observation data, like our bird example, where it just involves counting something, it's best to record that data in a table because it makes it a lot easier later on to look through that table and to analyze it. Okay, guys, thanks for listening to today's lesson. Tomorrow's lesson, we're going to look at tabulating data or putting it into a table. Welcome back, everybody. This is week 7, lesson 2 for Year 5 Maths on a Tuesday, and we're looking at tabulating data. Okay, so we're tabulating data today. That really just means putting it into a table. So you'll have collected your raw data. That's the data that you've collected either through a survey or through observation. That's your counts. And it's before we've tried to analyze it or sort it or tidy it up, it's what we call raw data. So you're going to create a table to organize your raw data. Make sure that your table has columns, rows, and headings. And we're going to look at how we can use tables to sort that data as well, to organize it. Okay, so raw data, this idea of raw data, it's really data that you've collected from somewhere. And before you've tried to tidy it up to make any sense of it, to put it in a table, put it in a chart, it's really fresh data that you've just collected. And it comes in many different forms. So here, down here, we've got data that's been collected through SurveyMonkey. I can see the respondent ID. So these are all individual respondents, all individual people who've responded to this survey. Question 1, question 2, and question 3. So the question 1 was about, what was their preferred pizza type, their age, and then their gender. So it could be something like that collected through a survey where it's nice and easy to manipulate. It could be something as messy as this up here. So we've got Tammy's response. She's 7. Here are her favorite things: turtles, cats, and barbecue chicken pizza. Well, from this, I can gather that Tammy's favorite pizza type is barbecue chicken pizza. Now, I did mention before that this idea of favorite things for this question, we wanted to find out preferred pizza type. But it's just using an example of how scrappy sometimes raw data can be. It can be on the back of a napkin. It's information, it's still data. Here we've got a tally, nice and simple. So someone's gone around with a sheet of paper and recorded on a tally. Here we've got information from interviews. So Billy, I'm 7 and I like Hawaiian pizza. So that's Billy's response, that's data. We've recorded it somewhere. Same with Sammy. Pepperoni pizza is my favorite, but then Supreme. Yep, so we know that pepperoni is a favorite, and then if she had to, she'd eat Supreme. So this idea that raw data really can come in many different forms. And the idea today is we're going to put that into tables to make it a lot easier to manipulate, to move around, and to make sense of it. Okay, so now you know what raw data is. Let's look about tabulating it or putting it into a table. So here we've got favorite colors. So we've got a sample of 36 people. So everybody can reply once with their favorite color. And it's already in a table here for us, but this is not really a workable table because the data is kind of scattered all over the place. I've got purple here, I've got purple up here. It makes it really difficult to count and to make sense of. So what I'm going to do is I'm going to put it into a table. And because this is categorical data, I'm going to have 2 columns. So the first one is color or favorite color. And the next one is frequency. So that's how many people responded that black was their favorite color, or how many people responded that blue was their favorite color, and so on. And then basically I just go through, count them up and put them into my table. It's that easy. But using this table format, now I can see that, well, okay, 7 is the highest value. So blue is the most popular color. And I've got orange and yellow are both 2, so they have the lowest value there. So they're the least popular colors out of this sample of 36 people. Now, sorting data. So here, let's go back to our pizza topping data. These are the people, our imaginary class that we've surveyed. I've actually got their names, the pizza, their preferred pizza, their age, and their gender. Now, this is before it's been unsorted. This is basically, this is my first respondent, Billy, then Jimmy responded next, then Susie and Sally and so on, and Tilly down the bottom was the last respondent. But if I want to, see, well, okay, how many people liked barbecue chicken pizza? Well, what I can do is I can actually go in my Google Sheets. So this is almost like the Excel version, the free version on Google Docs. I can put it into a table. And then in this ribbon here, I go all the way to the end and I see this thing looks like a funnel. So this is like a filter. And I select these top rows. And then what I do is I click on this and it gives me this little triangle thing, which is a filter. So it means that I can sort this data in different ways. So here I can sort this alphabetically. So I've got barbecue chicken, cheese, and then Supremes down the bottom. I can sort by age. So from youngest to oldest to youngest. The gender, I could have all the females or all the males there. I could sort alphabetically by name and so on. Makes it a lot easier to quickly review the data, having to go through here and go, okay, wait a second, I got one Hawaiian pizza here, one Hawaiian pizza here, one Hawaiian pizza here, and so on. Now, you probably wouldn't just have this table here. You can actually have another table with counts, but this is sort of the first thing you'd want to do is to put it into a table and then make sure you can sort it. So we've put our data into tables using Google Sheets, and we use this filter function to sort the data. So I could sort the names alphabetically, pizzas alphabetically, so I can group the pizzas, the ages from youngest to oldest or oldest to youngest, and gender as well. Now, for this exercise, we only really wanted to find out what the most popular pizza type was. But because I collected this other data here, I can also find out, what was the most common age of the respondents and what was the most common gender of the respondents. So here I know that there were more females to respond than males. Here I can see that it was pretty even age split amongst all of them, except there was one less 8-year-old because it's an odd number. And up here, this is the most important piece of information that I want, is that Supreme Pizza was the most popular pizza, closely followed by cheese and Hawaiian, and barbecue chicken. Not many people really wanted that. Now, we're not going to look at the two-way or three-way tables where we can actually see, we can kind of look at these data together where we can say, well, what was the most common pizza or most popular pizza among 7-year-olds? Now, this is a very small sample, so it's not really going to tell us a lot. But we could do that if we had a larger sample. But that's kind of why I'm sort of showing you that you can collect more than one piece of information in a survey. But for today's exercise, we only really want to know what the most popular pizza type was. And that's really it. So firstly, raw data just means data that's been collected but not sorted or analyzed yet. We can use tables to organize and sort collected data. It's a very powerful tool. Tables make it easy to review the data, so it's very easy to scan down the table and go, okay, this is the most popular pizza type, or this is the most common age of respondents. And lastly, tables can be easily turned into graphs, which we'll look at in the next lesson. Now, today's lesson on Tuesday, there is an activity that involves bar graphs. I'm going to be talking about that in the next lesson, so if you'd like to learn about that, feel free to keep listening and listen to tomorrow's lesson, which is for Wednesday. Otherwise, you can leave the table activity for later on this week. Remember, on Friday, you do have a catch-up day as well. Okay, I look forward to seeing you in the next lesson. Okay, this is your last lesson for this week. It's a little bit shorter because we've got the school disco tomorrow and then Friday's catch-up day. So today we're looking at column and line graphs. So we're going to learn how to create column and line graphs, recognize when it's appropriate to use a column graph or a line graph. So there are situations where it's better to use one or the other. Choose an appropriate scale for your graphs, so important. We'll look at that in a moment as well. Give your graphs a title which is appropriate, and also label both the X and Y axes. Okay, so firstly, let's just look at features of a graph because I'm going to be using this terminology or this language. The first one is, let's look at our axes. So our X-axis is our horizontal one going along here. That's this bit here. And then we've got our Y-axis, which is vertical. And along each of them, you'll see these markers. So here we've got 1, 2, 3, 4, 5. Now, I'm not entirely sure what this graph is going to be about because it doesn't have any labels on it. And then here we've got another set of markers, 1, 2, 3, 4, and so on. Now, this might be to a particular scale. It's not actually made clear or not. We'll look at scale in a moment. This bit here, where the two axes join at the 0, is called the point of origin or the origin, and it's where the X and Y axes intersect. It's always 0 there. Make sure that when you are doing your graphs, you're creating your graphs, they always have to have a title. This is because they might be shown in isolation. And if it doesn't have a title, people are like, what is this data actually about? I don't really know what it's about or when it's from, or it's so important to have a title. Similarly, it's really important always to label the axes. So here, this might be number of hours perhaps, and this might be number of birds or something that fly into my garden. So it's really important that this is labeled, hours, and this is labeled number of birds. Always label your axes. Even if you think, oh, it's a little bit obvious, it's really good practice to do it. Okay, column and line graphs. When should we use one or the other? Well, column graphs are really useful for summarizing and comparing categorical data. So we know that categorical data is data that can be put into groups, things like nationality, favorite sport, or favorite food. Those things can all be represented as groups. So nationality, it might be Australian, Chinese, American, Indian, and so on. They're all categories. They're not numerical values. Now, there is a crossover where we can have a range. So age can be a numerical value, like my age is 31 and 5 months, but it also can be represented as a category. So it could be like 18 to 35-year-olds, 36-year-olds to 40-year-olds, and so on. They can be kind of represented as categories. So it's just really important to remember that categorical data, it's in these groups or categories. Now here we've got countries, we've got Kenya, Algeria, Afghanistan, and so on. And this graph has labeled the X-axis, that's my horizontal axis, so I know this is by country. It also has a heading here, so I know what this graph is all about. It says population by country. And then on the side here, on my Y-axis, my vertical axis, I can see it's been labeled population in thousands, and it actually goes up by 5,000. And they've even added data labels on here. Now, this is a little bit confusing because I'm not too sure whether this means that the population of this country is 45,000 for Kenya. I'm pretty sure the population is a lot larger than that, but I'll just disregard that for now. Line graphs. When to use a line graph? Well, that works better with continuous data. So continuous data is data that can be measured on a scale. So it's usually numerical data, and it can be measured on a scale. So things like time, height, temperature, weight. Temperature can be measured on a scale. We know we've got, so we've got 0 degrees here. We've got, -1 degree, 1, 2, and so on. All these other things, because they're numbers, they can be represented on a number line. A number line essentially is just a scale. So they're all examples of continuous data. So here the data is Canadians going on holidays. This is the time data down the bottom here, and it's done by months, which has been labeled, but I also know these are months, January, February, March. And then this is the number in thousands. Also my Y-axis has been labeled of Canadians going on holiday. So this is the actual count here. And you can see how it tracks along. So the line graph shows me trends over time. So I can see it's sort of fairly steady here, kind of spikes here, then goes back down. Then it has this big increase over May all the way through to August. And then suddenly the data or the number of Canadians going on holidays drops quite significantly down here. And then it spikes up again at November through to December. So it kind of shows me trends, whereas here, this is about comparing on this side with my population. It's really just comparing different categories and counts for those different categories. It doesn't show me data over time. Okay, so let's look at our examples. We've got preferred pizza toppings for stage 3 students. That's my heading. It's nice and specific heading, and I've actually included the count here. So I've increased the numbers so it looks a little bit more impressive rather than our class of 15 kids. Here we've got the number of respondents is 147. So 147 stage 3 students responded to this. Here are my categories on my x-axis, and I've labeled it pizza toppings. It might actually, well, the heading here says preferred pizza toppings, so I know this is the pizza topping category down here. And this is the number of students, the count of the number of students that selected what their preferred pizza topping was. Now, instead of having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I do that, my graph either needs to be really big or it's really difficult to read. So instead of doing that, I've had a scale here where I go, well, 0 to 10 is one interval or one marker. 10 to 20 is another marker. So each of these markers, you can't quite see it here, represents 10 students. So I need to, when I'm drawing or creating a graph, I need to think about my scale, whether it's appropriate. And for these graphs, particularly for a column graph, you kind of want your x-axis and y-axis to sort of be similar lengths. Generally, your x-axis will be longer, but you don't want to have it where your y-axis is really low and then your x-axis is really long, because it kind of flattens the data. We're not going to look at that so much about misleading data, but you'll kind of get a sense of like, actually that seems kind of unreasonable. It seems to sort of squash my data a bit. So here I can see it's nicely spaced out. I can see the comparisons, the differences between each of the categories. So here I can see there's a difference between cheese and Hawaiian, Supreme, and so on. Now I've also added data labels as well, just to make it really clear. You don't have to do this, but I kind of like it, particularly where I want to be really specific about how many people like Hawaiian pizza. It just helps the person reading. Now they could go across here and go, okay, well, I've got this guiding line here which goes across to the pink bar, which is for Hawaiian, and it's a little bit lower than the top, so it's going to be slightly more than 40. Here on the right-hand side, I've got my line graph, which is showing time series data, which is data over time, and this is about the Snowy Mountain Dam capacity. Now, I just made this up, but this is for a year, for April 2020 to April 2021. So I put a kind of timestamp here as well, so whoever's reading this knows, well, what years are they talking about? You can actually see that from down the bottom, but it's nice to put it in the title as well, because someone's like, well, actually, I don't want to read data from 2020. I want to know what data from 10 years ago, from 2011. So here down the bottom on the x-axis, I've got month and year data. So April 2020, May 2020, and they're all evenly spaced out. So they're not kind of, one's not bunched together too close, and then kind of like April and May aren't bunched closely, and then June's all the way down here, because that's going to affect the shape of the data, and it's not actually going to represent really the true trend of it. On the y-axis, I've got dam levels, and this is by percentage of the dam that's full. And here again, I've used another scale, so I haven't done 1%, 2%, 3%, 4%, and so on. I've done it by intervals of 20%, so 20, 40, 60, 80, and 100. It means that my graph is nice and easy to read. I've tried to sort of space the months and the percentages kind of evenly. Otherwise, again, you can have like a really sharp looking line or a really flat looking line, which doesn't really show anything. But here it's nice and easy to read. I can see that we started off, just under 100. Now I haven't put data labels on this, but it goes down to about 90 and so on. This is more about seeing the shape of the data and how it changes over time. So it gets all the way down to 60%, and then it starts to increase again as we go through November, December. So maybe they had less rainfall in these months, and it kind of caught up with them when they got to October, but then started to have more rain through October and so on. It kept on increasing. So that's when to use column and line graphs. Really important to always have a heading. Always label your x-axis down here and your y-axis. Make sure that the intervals are evenly spaced on each of the axes. And choose where you've got a y-axis and you've got large numbers, choose a scale. Don't put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've seen it before. It's really difficult to read, and it's a lot of pain for you as well. Graphs aren't meant to be painful. They're meant to be nice, quick, easy ways for someone to understand the data. Essentially, you want someone to be able to look at this and understand the data within 1 or 2 seconds. You don't want them to be poring over it going, I don't really understand this. Graphs are meant to be nice and easy to understand. Okay, so here are the main ideas. Continuous data is data that can be measured on a scale. That's things like time, length, weight, height, distance, money. They can all be measured on a scale. They can all go on infinitely. It's best to use continuous data for those, particularly if they're over a period of time. So line graphs are great for time series data where it's over time. Column graph is better for categorical data where it's just like a point in time. So it's like, what is everybody's favorite pizza topping as of today? I've got my pizza toppings as my categories, and then I just do my counts and create my columns to compare them. Make sure you choose a scale for your graphs. You don't want to be doing, particularly for your counts, 1, 2, 3, 4, and so on, unless that's a reasonable scale. But where you've got like, numbers up to 1,000, you're not going to be doing all the way up by ones. You want to make it, is 20 or 50s or hundreds, probably hundreds for thousands would be an appropriate scale there. That way you'd only have 10 intervals if it's up to 1,000, or if it's in thousands, you probably have each interval as 1,000. So think about what an appropriate scale is for your axis. Make sure the markers are evenly spaced. This isn't so much of a problem when you're working online using Google Sheets or Excel, but if you're drawing it by hand, this is really important. And make sure you label each of the markers. So the markers, again, there are intervals on our axes. Make sure that they are labeled. So let's say it's 10, 20, 30, and so on. They need to be labeled. They can't just be there independently of themselves. And lastly, so important, I can't emphasize this enough, and this is somebody who has actually worked in data analysis before becoming a teacher. Always give your graph a title and label the X and Y axis. It's so important. You want to make sure that whoever's looking at it can very quickly understand what your graph is saying. There shouldn't be any question of a doubt, like any ambiguity. What is this really telling me? Yep, you want to make it really explicit. Now, separate to this video, I'm actually going to do a short video showing how to create graphs in Microsoft Sheets, which you all have access to through your G Drive. So that'll be a separate video. If you know how to do that, that's fine, but I'm going to go through that, showing you how to make bar graphs and line graphs, and also just how to sort data in a table. All right, thanks for your attention, guys. Good luck, and I hope you're enjoying this week on data. Bye-bye.